Imagine you wake up 10,000 years ago. No tools, no phone, no idea where you are. You look down. In your hand is a nicely shaped rock, and your mission is to create Wi-Fi. There are tribes nearby, but you don't speak their language. You're on your own. You look up wondering where to start. Lightning flashes across the sky, and suddenly it hits you. Wi-Fi needs electricity, but you can't just make electricity. You have to recreate nearly all of civilization first. The first rule, stay alive. You cannot invent anything if you starve. Your entire existence becomes about survival. You knap rocks into tools, fell trees, construct shelter. You learn which plants nourish and which ones harm. Same with the creatures around you. You endure countless injuries. Over time, it dawns on you that you cannot spend every moment just surviving. Civilization only progressed because people found moments of rest. So you turn to agriculture. You clear land, sow seeds, domesticate livestock, store surplus harvest. For the first time, you have abundance and free hours. Still 9,000 years from wireless internet, but now you can actually think. One day you discover unusual stones. Vibrant, dense, lustrous, like something from a curiosity shop. The challenge: transform these into functional materials. The solution lies in extreme heat. You fashion simple kilns, burn charcoal to intensify temperatures, test, fail, iterate. Then one moment, the contents of the furnace transform into molten matter. You produce something unseen in nature. You learn to pour and temper it. At last, you've unlocked copper and iron. Suddenly, your implements cut deeper and endure longer. The era of stone finally concludes. Metal enables machinery. Yet you cannot construct advanced technology by chance. You require measurement, forecasting, verification. So you build foundations. Counting becomes mathematics. Mathematics becomes geometry. You calculate angles, areas, how levers exchange force for distance. You begin recording everything. So knowledge survives beyond you. This single habit proves most vital. Then you push beyond survival needs. You pursue principles governing motion, curves, and transformation until you reinvented calculus. It turns out you possessed hidden brilliance. None of this fills your belly. None keeps you warm. Yet without it, everything that follows becomes impossible. Mysterious phenomena start making sense. Static discharge, lightning, attraction between magnets. You rub various substances together and study the resulting sparks. Eventually, you replicate what you witness in the clouds, electricity. But one spark is insufficient. You require power on demand. Thus, you engineer a steam-driven engine and conductors to distribute it. You identify which metals transmit current. You grasp voltage, amperage, impedance. Concepts humanity required centuries to understand. This is impressive. But how do you apply it? Link two separate locations with a wire and transmit a message. A telegraph emerges. For the first time, news outpaces a rider on horseback. You've invested years in mastering electrical science. Each solution spawns fresh questions. One day, while examining a circuit, you notice a small metal loop nearby illuminating whenever your circuit activates. This defies expectation. Electricity demands conductors. That's a fundamental principle. You investigate further. You increase the gap, insert barriers. Still it glows. When current alternates rapidly enough, it radiates imperceptible waves. These waves traverse air and solid objects. They have been passing through all matter and every being throughout existence. You've discovered wireless transmission. Now, communication needs no physical tether. Yet radio differs from Wi-Fi. That demands computing machines. No nearby electronic store exists. Even if one did, costs would be prohibitive. Computing requires silicon of almost unimaginable purity. Not 99% pure, not 99.9% pure, but 99.9999999% pure. Reaching that level necessitates industrial facilities and logistics that won't emerge for another millennium. So you pioneer those as well. From this silicon, you fabricate transistors, microscopic electronic gates. A single wireless chipset contains billions of them, each beyond visual perception, all coordinated perfectly. Now you assemble the rest. Storage, processing units, code, system software. You connect two machines with a link, the inaugural network. Then you construct a device to manage traffic between them. After countless ages, the system is finished. Many assume Wi-Fi is the breakthrough, yet it represents a culmination, the peak of a mountain constructed from every technological leap in human development. Now, with wireless connectivity, you might as well develop infinite scrolling and wagering on athletic competitions.